Just like distance and displacement are different ideas, speed and velocity are also different. The speed of an object is a scalar quantity. That means it has no direction. It has the symbol v with no arrow above it because it's a scalar. The unit of speed is the meter per second, and its definition is simply how fast you are going. Speed is just looking at how fast you went over a particular trip. Because of that, its formula has no vector quantities in it. The speed of an object is made up of the object's distance traveled, remembering that the distance an object travels is the total amount it went, no matter whether it changed direction or came back to where it started. We're just interested in how much it actually went, divided by the time. Written out in symbols, this is v equals d over t. The velocity of an object is quite similar. It's still meters per second, and the formula looks very similar. But because it's a vector, the other things are a little bit different. Velocity is a vector. That means direction does matter, and your answers must all give a direction. The symbol for velocity is v with an arrow above. The arrow shows that this is not speed, it's velocity, which is a vector. The unit is also a meter per second, but the definition is different. The definition for velocity is how fast you are leaving your start position. The formula makes use of displacement, which is also a vector. Velocity is equal to displacement over time. In symbols, this is v arrow equals d arrow over t. So to recap, speed equals distance over time, and velocity equals displacement over time. Two formulas that look very similar but will give you different answers because of the fundamental difference between distance and displacement. To help you understand, think of a person running around a track. As the person runs around the track, they could be running quite fast. Say that this was a 1 kilometer track. For every time they go around, their distance is 1 kilometer. However, every time they go around, they come back to the place where they started. So even though they've covered a distance of 1 kilometer, they've actually covered 0 kilometers of displacement. 1 kilometer is very different from 0. Because speed uses distance, the object could have a speed. The person is traveling at quite a fast speed, a kilometer around the track. However, because velocity uses displacement, which is 0, the velocity of the person running around the track is actually 0. So if you really want to go annoy people, go out to the closest track, watch people running around, and yell at them, "Hey, Your velocity's 0. And hey, didn't you know you're not actually going anywhere? And see how they like that. Here's an example with math to show you how speed and velocity are different. A dog walks 10 meters north in 5.2 seconds. Then the dog paces back 17 meters south in 6.1 seconds. What was the dog's distance, displacement, speed, and velocity? To solve this problem, I'm going to separate my page into two different sides. I'll call the left side the scalar side, and the right side the vector side. On the scalar side, I'm going to calculate distance and speed. On the vector side, I'm going to calculate displacement and velocity. The distance is all of the little distances added together. 10 plus 17 equals 27 meters. This is my displacement. The time it took to walk this 27 meters was 5.2 plus 6.1, which equals 11.3 seconds. The speed is equal to distance divided by total time, which is 27 over 11.3, which is 2.38938 meters per second. And looking at significant digits, I'm allowed 2 significant digits based on the numbers I started with. So the rest go. 8 rounds the 3 up, and my speed is 2.4 meters per second. So now I've found the distance and the speed. For the vectors, I find displacement by combining the 10 and the 17 again, but this time I take their directions into account. The north on the 10 gives me a plus 10. The south on the 17 gives me a minus 17. This gives me negative 7 meters, or a displacement, converting the negative back into a direction, of 7.0 meters south. This is my displacement. The time it took to do this is still 5.2 plus 6.1 equals 11.3 seconds. Because time is always a scalar, time will be the same no matter what you're looking at. V arrow equals d arrow over t. Velocity equals displacement over time. This is 7.0 meters south divided by 11.3 seconds, which equals 0.619469 meters per second. Looking at sig digs, I'm allowed 2 sig digs, so everything else goes away. The 9 rounds up, and I get a velocity of 0.62 meters per second, and I take the direction from the displacement, so it's south. And that's velocity. Here's some vocab that you need to understand for speed and velocity. There's a difference between instantaneous v and average v. Instantaneous v is the v, which is speed or velocity, at a particular instant in time. Because the instantaneous speed is very difficult to calculate, what we actually calculate most of the time in our questions is the average v. The average v is the average of all the instantaneous v's over a time range. So while instantaneous v is what we often are talking about when we say whether something's going fast or slow, the average v is what we actually calculate. The average v is given by the total distance over a time range divided by that total time range. Most of the time in physics, we're looking at objects that are going at a uniform speed. Uniform speed means constant speed or velocity. This is another way of saying having the same speed or velocity over a period of time. This is a little bit like if you're going to put your car into cruise control. You want to keep it at the same speed for quite a while. That means you have a uniform speed. The word uniform is like wearing a uniform. If you wear a uniform, everyone's wearing the same thing. Uniform means same. Here's an example to help you understand how to calculate average speed. Sometimes you'll be given a question with two speeds and asked to find the average of those two speeds, like this. A dog runs at 10 meters per second south for 20 seconds, and then runs back at 15 meters per second north for 5 seconds. What was the average speed and velocity? This question's tricky because we're given two speeds and asked to find the average of the two. Most students, when they see this question, want to do this. They say, well, we have two speeds, so we go the two speeds added divided by 2 equals some average. But that is not true. We can't do this. The reason for that is because the 10 meters per second is done for much longer than the 15 meters per second. Because the 10 meters per second is done longer than the 15, the average should be closer to 10 than it is to 15. So here's how we actually do it. We use the fact that the average v is equal to the total d over the total t. What we actually have to calculate to find the average v is the total distance and displacement. So again, dividing my page into two sides, I'm going to find the speed on one side and the velocity on the other. Before I do that, I need to actually find the d's that it traveled. In other words, I want to find how far did it travel in this 20 seconds and how far did it travel in this 5. To do that, I rearrange v equals d over t for d. This gives me d equals v times t. So the first distance, we shall call it d1, was traveled at 10 meters per second. This gives us 10 meters per second times 20 and that's 200 meters traveled in a southward direction by the dog. The second distance we shall call d2 was traveled at 15 meters per second for 5 seconds, which gives us a displacement of 75 meters, and it was traveling north at that time. So now we have the actual distances, displacements covered in that time range. We can find the speed and velocity. The distance traveled over the whole period of time was the 200 meters plus the 75 meters, which was 275 meters. The total time that it traveled for was 20 plus 5 seconds is 25 seconds. So the speed was v equals d over t is 275 divided by 25 equals 11 meters per second. The velocity comes from the total displacement. So that's going to be the first displacement plus the second displacement. We have to use the directions. This is 200 plus 75, but 200 is negative and 75 is positive because of the south and the north. This gives us an answer of negative 125 meters, or 125 meters south. The time is still the same. It's still 20 plus 5 makes 25 seconds. The velocity is equal to the displacement over time, which is 125 divided by 25, which equals 5.0 meters per second. We give it the same direction as our displacement, so it's south. When you want to calculate the average speed or velocity, and you're given two different speeds or velocities, you have to find the distance traveled in the first, the distance traveled in the second, and then find the total distance or displacement traveled, so you can calculate it using v equals d over t.